understanding-ish situation. Okay, this is lesson 5.4 homework. It's only 6 questions, I think. Some of them are really quick, like this one. How is an exponential growth function of the form f of x equals a times 1 plus r to the x power related to an exponential function in the form of f of x equals a times b to the x power? It says, how is this related to this? Before we look at our answer choices, let's analyze what this is compared to this. What do you notice that's the same about them? What do you notice that looks a little bit different? What do you notice that is the same about this exponential growth function and this exponential function, the basic function form? They both have a, and what does a represent? You can check your notes. The initial value or initial amount. I mean, you can call it starting value, beginning value, initial value, starting amount, initial amount. So they both have a as the initial amount, right? What do you notice about them that's different? Yeah, one of them has parentheses. What's inside the parentheses? 1 plus r. Do you guys remember what that's called? This whole thing here? It's okay if you want to check your notes. What? You may not have written it down. It's 2 words. It starts with GF. Growth factor. Very good. This represents the growth factor. And what is the same as the growth factor over here? B. What do we call B? What? Constant ratio, very good. So we have the constant ratio being raised to the x power, and here we have the growth factor being raised to the x power. They are essentially the same thing. But in the basic exponential function form, we just call it the constant ratio. With an exponential growth function, we're very specifically having the plus r, because we're adding the rate because we're saying it's growing. This exponential function technically is for growth and decay. This one is specifically for growth. So let's look at our answer choices. We decided that A represents the initial amount. So can you narrow it down to 2 answer choices based on what we decided about A? Yeah. Tell me 2 answer choices that so far are correct, just in the first part of the sentence. Abby? D and B. So far, D and B have the correct first part, because the other ones don't make any sense. It says the value of A is the growth factor. A is not the growth factor, it's the initial amount. So far, B is correct, the value of A is the initial amount, the value of A is the initial amount. Let's look at the second part of the sentence. This says B is equal to the growth factor R. This says B is equal to the growth factor 1 plus R in parentheses. Again, this one is saying B is equal to just R. This one is saying that B is equal to the whole growth factor 1 plus R. Which one's correct?
D.
D is correct. Did you say B? Yeah. It's okay. So B is equal to.
I didn't read it fully.
Okay. Yeah. It's this kind of question is it's really good to practice this understanding, like the language of these formulas, because it really helps us remember what they're used for, how they're used, why they're used. So it also helps us understand that these formulas are really the same thing. This one's just much more specific for exponential growth. But this little guy in parentheses, the 1 plus r, is the same as b. We just call it a growth factor, 1 plus r. So your answer for that is D. Okay? You're welcome. On to the next one. Okay. The asymptote says what? Oh gosh, I can't even get all the words on this one. Oh my gosh, I gotta make it smaller. Okay.
It's the biggest one.
Yeah.
I don't know.
Try to get it like small enough that I can see everything, but big enough that I can see everything. What is the asymptote of the graph of an exponential growth or exponential decay function? Explain your reasoning. Let's read our answer choices. Since exponential growth and decay functions are both modeled with f of x equals ab to the x power, the asymptote of the graph is y equals a. What is y equals a? It is y equals 0. Y equals a, that doesn't even make any sense. So b and d, the graph y equals a, that doesn't make any sense. Y is the output. So a is wrong and d is wrong. Y definitely does not equal a. The asymptote is y equals 0. So it's going to be either b or c. Let's read b first. I honestly don't know. It always generates a different order of the answers. So I'm honestly like reading through them to decide which one it is. Let's start with b. Since exponential growth and decay functions are both modeled with f of x equals ab to the x power, the asymptote of the graph is y equals 0. And then this answer choice is exactly the same, except it says, since the exponential growth and decay functions are both modeled with f of x equals a times 1 plus b to the x power, the asymptote of the graph is y equals 0. Now again, we're comparing ab to the x power and a times 1 plus b to the x power. What do you see that's just totally wrong with one of those formulas? Ricky, what's wrong with it?
There's not an R.
Yeah, they put a B here. It's supposed to be an R, right? And that's not a book mistake. They're actually trying to see if you know what the function would look like if we wrote it out. Now, it also says, since exponential growth and decay, now if you haven't had my class yet, we haven't totally talked about this today yet, but it says and decay. Ricky and Abby and Callie, we know that exponential decay would have a minus sign, right? We would have to subtract the rate. So there are two things wrong with this. First of all, it's not B, it's R. Second of all, if it's growth and decay, it would have to be plus or minus. So that alone tells us that C is not right. And we can say that growth and decay functions are both modeled with this, even though technically their more specific models would be a times 1 plus r to the x power, or a times 1 minus r to the x power. On your EOC reference sheet, it looks like a times 1 plus or minus r to the x power. But we also said that this function does mean the same thing as this. That's just a little more specific. So your answer is, in my case, B. I don't know where it's listed in your answer choices. Okay? Does that make sense? I just have to laugh at the talkies. All right. Suppose a city with population 300,000 has been growing at a rate of 8% per year. If this rate continues, find the population of this city in 17 years. What formula are we going to need to solve this? Yes? Yeah, it's called the exponential growth. Exponential growth. Now we see that it says it's growing, so we're going to need our exponential growth. You guys can write this down. Function, which is f of x, and if you don't have this memorized, it's totally fine. It is in your EOC reference sheet. F of x equals a times 1 plus r plus, because it's growing, to the x power. Then we just have to fill in our amounts. What is, not the number, but what does a represent again for all functions? Initial amount. So we have f of x equals our initial amount, which is what? 300,000. Is your number different? Okay, so you write down your number, not my number, okay? For me, it's 300,000. Open parentheses, I'm gonna have 1 plus my growth rate, which it gives me is, my rate is 8%. Do you guys have a different rate?
Yeah.
Okay, write your rate. Now, when I write 8% here, I'm not gonna write it with a percent sign because that's not how we calculate percentages. How do we calculate percentages? Decimal. So instead of
Wait, and you just carry the 1.
this?
Yeah.
So just, you mean when we add them together?
No,
This,
originally-
you mean just continue the 1 down here? Yeah. When you said carry the 1, I was thinking like addition where you carry the 1. So the 1 stays the same always. The 1 simply, it's a constant, it's not a variable. A constant stays the same in a formula. It represents this.
So mine's gonna be 1.
Yours is gonna be 1 also, it's always gonna be 1. Because this is the standard formula. So no matter what your problem is, it's always gonna be a 1. And then our growth rate is 8%, so I'm gonna write that as 0.08. Now, our input is what? X is the input. What do we put as our input though? 17. It's 17 for me. However many years it says for you, that's your input. Yes? Oh, okay. Then, now you don't have to do this, but it's just good practice to show that since you are inputting 17 years, we are going to represent that in our function notation just by saying the function of the input 17, meaning what we're gonna get out of this machine when a 17 goes in is going to be this calculation simplified, right? So you can either do your EOC calculator and type this in exactly as is, or if you want to simplify it on your own, you could do 1.08 on your own. Do you guys like doing it? You can do it on your EOC calculator. If I do it on my EOC calculator, which I have, I'll just get it. Do you not like to use your EOC calculator? I highly recommend using an EOC calculator for this because you can type it in exactly as it is. Now remember, we don't type this part in. This is your output. That's your answer. Okay, we just type in the actual, it's in the links at the top of your course page. So I'm gonna type in, for me it's 3,000, open parentheses 1 plus 0.08, close parentheses. I'm gonna raise it to the 17th power. You see how easy that is? I don't even have to press enter. It gives me my number right here, 11,100. And it's probably telling me to round to the nearest whole number. So yeah, that would be 11,100 people Oh, did it tell? Oh, did I put 300,000 or did I put a different
You
number?
put 11,100.
I put 3,000. I was supposed to put 300,000. Whoops.
So
300,000. Whoops, I'm not supposed to put commas here. So it's oh gosh. It's 1,000,000. Can I copy and paste this? There we go. I'll copy and paste that.
how do I do?
Yeah, I'll copy it. So your calculator is only going to give you the right answer if you put in the correct numbers, which I did not. There we go. I'm going to put my commas in here. And let's try that again. Well done. And I should have used logic to see that my number would not work. If it starts at 300,000 and it's growing, I shouldn't end up with 11,000 people, right? I should have used my logic to spot that wrong answer before I submitted it. Silly me. Okay. So this one has 5 parts, but it's only because it's asking you to break it.
Where are we on now? What are we doing?
I went to the next problem. Do you still need help with yours?
I need help.
Really? So yours was 700,000 with a rate of 5% to the 24th power. Okay, you got it. Just round to the nearest whole number. How do you round?
Oh, I don't. Sorry.
It's okay.
I don't know where helping. I don't know which question
Okay, so rounding to the nearest whole number means get rid of all your decimals, but represent the highest decimal value with your ones place. So yeah, you're gonna round to this place value, your ones place. You're gonna look to the one to the right and say, should I move this up or stay the same? Should 9 go up or stay the same? Yeah, so 9's gonna go up to 10. But that 10 has to be carried over to this. Yep, so this would turn into 7, 0. Who else needs help? Can I see your, this says 0.4 and you wrote 0.8 in your calculator. Can you have a copy of mine? Now remember to round to the nearest whole number. Why, wait, did you say raise to the 2 power? Do you mean round it?
Yeah.
You don't know how to round numbers either?
Well, I know my round is just asking if I have to or an answer.
It's asking you to round to the nearest whole number. It says round to the nearest whole number.
Oh, yeah.
Girls, did you get your answer correct? Melanie and Angeline? You got it? Okay, good. Abby, did you get yours correct? Do you need help? So Emily, you're rounding to the nearest whole number.
Yeah.
Which digit is going to be possibly changed? Possibly. Where is your first whole number place value? Very good, the 8. What number do we look to decide if it's going to go up or stay the same? That's correct. Is that going to make it go up or stay the same? Good. So we erase all of those decimal numbers. That's it. Abby, need help? Okay, so did you write out your function? I don't see it written out. I just see 300,000 down. Can you start it on this side of the notebook so you have room to finish the equation? Because you're starting over here, you're going to run out of space. Ricky, did you get yours? And Emily, you got yours, right?
Yeah.
Do you have a question? Do you need help with something? Well, we function, we can copy exactly that, and then we can fill in. I don't know how to write a function. I just wrote it for you, Abby. All you gotta do is fill it in after you write it. Okay. Now, what do we fill in for A?
This.
Minus homework. Zach, you can do better than that, right? Abby, focus please. What value can we substitute for A? What does A represent? Nope. The initial amount. What is the initial amount in the problem?
I'm just finding myself.
No, what does initial mean? What does initial amount mean? Yeah, the starting amount. What is the starting amount? 300,000.
What? Did you see the chicken off the road? Oh, yeah. I told you that
Good. Then you have 1 plus. So put a 1 plus. Okay, now you need R. What does R stand for? Start. Yeah, rate. And what rate does it give you? Yeah, 2%. How do you write that as a decimal?
Yeah. But I'm gonna show you how I'm feeling. Actually, technically, the one
Good.
is
No, that's not right.
the shortest.
How do you write 2% as a decimal?
Is the initial amount 3,500?
Here or like specs?
3,500 what? Where?
35,000.
Oh, are you?
Wait, hold on, let me redo that.
No, your initial amount's 14,000. Okay, 0.02, very good. Close your parentheses. And what is our x value, our input value? 22 years, very good. Now you're going to type this exact thing into your POC calculator, and then you're going to round it to the nearest whole number, okay?
Whoa.
Thank you for being patient, I'll be with you in 1 minute.
Not really big.
Yeah.
I figured out the next one.
Great.
We can go to the dance. Like animation. Yeah.
Don't do thumbs.
How many years is this? Just 1 year?
17.
7 times.
I don't even know.
So,
Lunch it.
9,520 plus 14,000.
I'm just guessing. I want lunch it.
23,520.
Probably.
Nope, not to the second power, to the 22nd power. Yep. Good. That's it. Now we have to round to the nearest whole number. She's so close.
I'm 100% healthy. Actually,
Nice sweatshirt.
Yes.
I have allergies.
Do you know how to round to the nearest whole number? Okay. Show me what place value represents the nearest whole number. Nope. No. A whole number would be the one. The ones place. What digit is in the ones place? No, that's the 10th place. The ones place. It's the very first whole number place value. No, that's the 10,000. It's the 3. That's the ones place. That's rounding to the nearest whole number. Rounding to the nearest whole number means just give us a whole number and don't show us any decimals. But this place value, this decimal place value, does have value that we may need to represent with this number. Is this big enough that we should represent it by going up? Yes. So what should the 3 change to? Good. And what should happen to all this decimal places?
And I died.
Good. You don't actually have to write the 0.0000. You can just write them out. Okay, continuing with, what number is this? 4. Number 4. This is number 3?
No, it's number 4.
Okay, good. Oh my gosh. All right, so the number of students enrolled at a college is 14,000 and grows 4% each year. Complete parts A through E. The initial amount is?
14,000.
Good. Did you guys have a different initial amount?
No, I have 14,000.
Whatever your initial amount is, put it in. Yes. The percent rate of change is 4%. So the growth factor B is 1 plus, what would it be for this? 0.04, very good, which would equal 1.04, good. They really should have put this homework question as the third, as like, I think they should have put this homework question before the other questions. Because I think this walks you through it better and then they,
I know.
anyway, that's just my opinion.
No, I stopped doing it.
To find the number of students enrolled after 1 year, you would calculate 14,000 times 1.04. If it's just after 1 year, you wouldn't need an exponent, right? Because the exponent would already be an invisible 1. Complete the equation y equals blank times blank to the blank power to find the number of students enrolled after X years.
Could it be 14,000 times 1?
Yep, 1.04. And then what would the exponent be? X, very good. When it says after X years, it's saying that we're just making a formula for it. We're not actually trying to solve anything right now, but I'm guessing that they're going to have us put an input in there. Use your equation to predict the number of students enrolled after 23 years. So we are going to put in our calculator 14,000 times 1.04 to the 23rd power.
Because how'd you get 23?
Because it tells us after 23 years. That's the question.
Oh.
So 14,000 times 1.04 raised to the 23rd power, representing 23 years. What is it? Does it want it rounded down to the nearest whole number? So mine would be 34,506. 34,506. Raise your hand if you need help with yours. Are you having trouble with yours?
Yeah, you're going so fast.
Okay. We're doing the same problems that we just did, where they're just asking for little baby answers in between. Yeah. Yeah, that looks good. Yeah. I'm pretty sure you can put your multiplication sign like that. I use parentheses, but that should be good. Yeah, we don't do, or you just having trouble because you're putting commas in there?
then we rounded it to all numbers.
It's 276.
Yeah, you just like copy the whole thing, but just, you have to make sure that you it's rounded. You can copy the whole thing and then round in your answer if you want.
What?
We'll just eat
It
it.
said wrong?
Yeah, I think it's wrong.
Okay, did you round to the nearest whole number?
Yeah.
Let me see.
But this can't.
Right, so 27,600, let me just make sure your numbers are correct. So, what was your question? 3, 10, so it would be 14,000 times 1.03 to the 21 power. Let me see your calculator.
Oh.
Did you put 23? Yep, you guys gotta make sure you're putting in the number. Emily, go back, go back. You put 23 as the exponent. It's to the, this says after 21 years.
Kelly.
Cal.
Bro, I put one in that. And then
Is everybody good? Can we move on? Oh, this is easy. A table for a function f is given to the right. Determine whether the function f represents exponential growth, exponential decay, or linear growth. Find a formula, and then the second part will be to find the formula for the function f. Yeah, it looks like exponential decay to me, because as x is increasing, as we're getting further to the right on our coordinate plane, the function is going down. Our y values, our output is decreasing. So, you're right. Now, is it decreasing by, is it linear decay, where it's just decreasing by the same number every time? Nope, it is, you can see that it's easier to see with this. 9 divided by 3 is 3, 27 divided by, so in terms of it being multiplied times a certain thing, it's being multiplied times 1/3 to get to each next value. So, do you guys understand that, how it's being multiplied times 1/3? The way to solve that is to take your y value and subtract it, not subtract it, divide it by the previous y value. So 3 divided by 9 equals 1/3. 9 divided by 27 equals 1/3. So that's what it's being multiplied by to get to the next y value. So you're right, it is exponential decay. Is yours similar to mine? Is it exponential decay?
Yeah.
You're all exponential.
Great. Why does it say final check? Is it?
No, it's because
Yeah,
it's
it's
only
only
3.
three.
Yeah.
Oh, you only get one shot for it? Okay, so this is asking for the function. Now, for the function, I need my starting value, my initial amount, times my constant ratio to the x power. What's my starting amount?
243.
243, very good. So the function of x equals 243. Do you guys understand why it's 243?
No.
Yeah.
Because of 0.
Yes, very good. Because if this is where it's starting, x is 0 on the graph, it's basically asking for the y-intercept. So 243 would be where it's starting, and then it's going down. So 243, and then the constant ratio is, for me, 1/3 to the x power. So you would have to see what your constant ratio is by taking any y value and dividing it by the previous y value. So 1 divided by 4 would be a 4. Yeah. 4 divided by 16 would be a 4. Yep, and then to the x power. Anybody else need help on this one specifically?
Put it in like that.
Yeah. Just don't type f of x because it's already there.
Thank you.
You're welcome. All right, one more. Similar question. A table for a function f is given to the right. Determine whether function f represents exponential. Wait, what? Let me see.
Oh, wait, do I have to put the X?
Yeah, you have to put the x. Exponential growth, exponential decay, or linear growth? Well, let's see what's happening. As x is increasing by 1, what is happening to
It's going up.
the output? For me, yeah, it's going up, but we have to decide, is it going up in a linear way? And is it adding or is it multiplying? So we're going to have to, now what we could do is, again, test to see if we have a constant ratio by taking a y value, dividing it by a previous y value. So that would be 25 over 10, which is 25 would be 2.5. Now let's see if that happens again. 10 divided by 4 is also 2.5, right? Is it? Yeah, because that would be 5 over 2, and that'd be 2.5. Okay, so and then 4 divided by 1.6. Is that 2.5? 4 divided by 1.6 is also 2.5. So each y value is being multiplied times 2.5 to get to the next y value. That is growth, and it's exponential because it's multiplying, multiplicative. So it's exponential growth. Or do you guys also have exponential growth on yours?
Every single one of the questions are. Just like the two.
I know. Whoops. Oh. And then does it just ask for the function? Then it just asks for the function. So my growth rate is, or my constant ratio, I should say, is my 2.5, right? Is being raised to the x power. And then my starting value, this is a little tricky, it's not, for me, it's not 0.64. What's my starting value? 4. Very good. Because it's the y-intercept. It's where x is 0. Yeah.
You had 6 questions.
I don't know what it would be. 0.64, then 1.6, then 4, then 25.
All right, that's it, right, for the video?